Hello, Math 2 students. Today we are going to learn how to factor polynomials when a does not equal 1. First, a quick review. If a equals 1, we want to find two numbers that multiply to c and add or subtract to b. In our problem, a is 1, b is 1, and c is negative 12. We know that our c is negative, so our signs will need to be different. We also know that our firsts will multiply to x squared. So the first term in each binomial will be an x. Now we need to find a number that will multiply to negative 12, but those numbers will also add to a positive 1x. So our choices are 1 and 12, 2 and 6, and 3 and 4. Well, the only numbers that have a chance of multiplying to negative 12 and adding or subtracting to positive x are 3 and 4. So now we need to check our answer. Our first will be x times x, which is x squared. Our last will be negative 3 times 4, which is negative 12. And if we add our outers, 4x, and inners, 3x, those like terms come out to positive 1x. And we know that we have factored the polynomial correctly. In this problem, we have a second degree trinomial where our a value is 2, our b value is 28, and our c value is 48. Normally, I would say that we need to find two numbers that multiply to 48, but can add or subtract to 28. This will not work on this problem. If your a value is positive 1, it would work. But if your a value is anything else, you need to start by trying to find the greatest common factor. Since our a is 2, my advice is this. If your a is not equal to 1, factoring is guessing, and guessing without checking is just caveman crazy. Any animal, insect, or caveman can make a guess. What makes you a more intelligent form of life is that you can determine whether or not your guess will lead to a successful result. To correctly factor 2x squared plus 28x plus 48, our first step will be to take out the greatest common factor. The 2x squared is prime, so the prime factorization is just a 2. The 28x, 28 has a prime factorization of 2 times 2 times 7. And 48 has a prime factorization of 2 times 2 times 2 times 2 times 3. As you can see, each of the terms has at least one 2. Now, we need to think 2 times some number that we don't know will give us 2x squared. And 2 times some number that we don't know will give us 28x. And 2 times some number that we don't know will give us 48. And it turns out that 2 times x squared will give us 2x squared, 2 times 14x will give us 28x, and 2 times 24 will give us 48. Now we have taken out the greatest common factor. When we look at our second degree trinomial that remains after taking out the common factor, we can see that our c value is positive and our b value is positive. So our signs are going to be the same, and they're going to be positive. Our firsts need to have a product of x squared. So the only way to make that happen is for our first terms in each binomial to be x and x. Now, since our trinomial that we're working with now, after taking out the 2, has an a value of 1, we need to find numbers that multiply to 24, but add or subtract to 14. Our choices are 1 and 24, 2 and 12, 3 and 8, or 4 and 6. The only possible choice that has a chance of adding or subtracting to 14 is 2 and 12. If a is not equal to 1, factoring is guessing, and guessing without checking is just caveman crazy. So now we need to check to see if we have the right answer. When we check our first, x times x is x squared. When we check our last, 2 times 12 is 24. When I check our outers, 12 times x is 12x. And our inners, 2 times x is 2x. And when we put our like terms together, 12x and 2x makes 14x. And 14x is the middle term that we're looking for. When you factor the remaining trinomial plus you have the greatest common factor on the outside, that is called factoring completely. So we have factored the polynomial 2x squared plus 28x plus 48 completely. On this problem, we have an a value of -4, a b value of 19, and a c value of 5. So we're going to start by trying to take out the greatest common factor. But 4 is 2 times 2, 19 is prime, and 5 is prime. So there is no number that 4, 19, and 5 have in common. So some people might think at this point that there is no greatest common factor. But one thing that you need to learn about this type of problem is if your a value is negative, that is not good. So you want to take out a greatest common factor of -1. So -1 times some number that we don't know is -4x squared. So that'll be 4x squared. -1 times -19x will give us positive 19x. And -1 times -5 will give us positive 5. So now we will be factoring the trinomial 4x squared minus 19x minus 5, which is much easier than factoring a trinomial with a negative a value, which is what we had when we started. So there's our greatest common factor. Now we're going to factor the trinomial that remains. In this problem, our c is negative and our b is negative. So we have to have signs that are different. We need to find two numbers that multiply to 5 but add up or subtract to 19. Obviously, there are not two numbers that multiply to 5 that will add or subtract to 19. But in this problem, we have to consider the 4, because when we multiply our firsts, the 4 will make a difference in what our product is. And when we multiply our outers, the 4 will make a difference in what our product is. So we need to take a look at 4, which could be 1 times 4 or 2 times 2, and 5, which is 1 times 5. The good thing about this problem is that 5 is prime. So we can start the problem by knowing for sure that we want a 1 and a 5 in our last spots. So now we just need to make a guess. Are we going to use 1 and 4, or are we going to use 2 and 2? I'm going to start by making the guess 2 and 2. So it looks like the problem might be done, but factoring is guessing, and guessing without checking is just caveman crazy. For our first, 2x times 2x is 4x squared. For our last, -1 times 5 is -5. Our outers, 2x times 5 is 10x. And our inners, -1 times 2x is -2x. And when we put those like terms together, we get 8x, which is not the middle term that we're trying to find. So those are not the correct binomial factors. What do we do now? Well, we know that the 1 and 5 are correct. The only difference we can make is instead of choosing 2x and 2x, we can choose 1 and 4. And so now you might think we're done. But factoring is guessing, and guessing without checking is just caveman crazy. Our first x times 4x is 4x squared. Our last, -1 times 5 is -5. Our outers, x times 5 is 5x. And our inners, -1 times 4x is -4x. When we put our outers and inners together, that makes positive 1x, which is not the middle term that we're looking for. So again, those are not the correct binomial factors. So now we've already tried 2 and 2, and we've already tried 1 and 4. Our next strategy is to switch the position of the 1 and 4. So now that looks like we might have the right answer. But factoring is guessing, and guessing without checking is just caveman crazy. Our first 4x times x, 4x squared. Our last negative 1 times 5, negative 5. Our outers 4x times 5x, which is 20x. And our inners, negative 1 times x is negative x, which comes out to positive 19x, which is not the middle term that we're looking for. We're looking for negative 19x. Again, those are not the correct binomial factors. So we've tried everything. Our last chance is that we switch the positive sign and the negative sign. So we have been operating with the 1 as a negative and the 5 as a positive. But now I'm switching them, and my 1 is positive and my 5 is negative. And factoring is guessing, and guessing without checking is just caveman crazy. Our first 4x times x is 4x squared. Our last positive 1 times negative 5 is negative 5. Our outers 4x times negative 5 is negative 20x. And our inners 1 times x is x. When we put those like terms together, we get negative 19x, which is the middle term that we're looking for. And finally, after guessing and checking several times, our problem is now factored completely and correctly. On this problem, our A value is 8, our B value is negative 10, and our C value is negative 12. So we need to find the greatest common factor because our A is not 1, it's 8. So 8 is 2 times 2 times 2, 10 is 2 times 5, and 12 is 2 times 2 times 3. So all three terms have at least one 2. So now we need to think of the number that 2 multiplies by so that we get a product of 8x squared. And that will be 4x squared. So 2 times 4x squared is 8x squared. 2 times negative 5x is negative 10x. And 2 times negative 6 is negative 12. So our greatest common factor is 2. Now we're left with a problem where our A value is still not 1. So we're going to take our greatest common factor, put it in front. We do know that our C value is negative, so our signs have to be different. And now we need to find 2 firsts that multiply to 4 and 2 lasts that multiply to 6. So on this problem, we're just going to start by making a guess. I'm going to start with x times 4x for my firsts, and I'm going to start with 1 times 6 for my last. There's no reason for that besides I'm just making a guess. Now, factoring is guessing, and guessing without checking is just caveman crazy. Our first x times 4x, 4x squared. Our last negative 1 times 6 is negative 6. Our outers, x times 6 is 6x. And our inners, negative 1 times 4x is negative 4x. And when we put our like terms together, we get 2x, which is not the middle term that we're looking for. So those were not the right binomial factors. So now I'm going to keep my x and 4x where they were because I do not want to change too many things at once. I'm going to change one thing at a time. And instead of using 1 and 6, now I'm going to use 2 and 3. And again, this is just a guess. Factoring is guessing, and guessing without checking is just caveman crazy. Our first x times 4x, 4x squared. Our last negative 2 times positive 3 is negative 6. Our outers 3 times x is 3x, and our inners negative 2 times 4x is negative 8x. And when we put our like terms together, we get negative 5x, which is the middle term that we're looking for. And this time on our second guess, we have factored the polynomial 8x squared minus 10x minus 12 completely and correctly.